Okay, I'm going to work through some of the questions in the electrical circuits practice quiz. So I have it open here in Brightspace in a preview of the quiz. So let's get stuck in. So question 1, you're asked how many nodes are in this circuit. So I'm going to try to explain a bit about what's going on in each of these questions as we go through, just in case anyone is still unclear about some of the concepts. So in the circuit that's shown here, I'll just switch over to the paper version here so I can write on it. In the circuit there are a number of elements. So what we mean by an element is anything like a voltage source or a resistor or a capacitor or an inductor. So these are all examples of elements. In this circuit there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements altogether. And what we mean by nodes is it's the points in the circuit where elements meet. So for example, here's a node up in the corner here where R1 and V1 meet. And this is an example of what we call a binary node because it's a node where only two elements meet. The other type of node is what we call a true node, which is where 3 or more elements meet. So here's an example of a true node here. So you can see R1, R2 and C1 are all connected to this node in the circuit here. So I'm going to colour in the nodes in the circuit just so we can see them all. Let me just pick a different colour maybe for each of the nodes here. So we've got one big node which spans this entire area of the circuit here. So let's call that node number 1. And then, as I was saying, we've got one node here. Let's call that node 2. And here's another node. This one's a true node. Let's call that 3. Here's another true node. Let's call that one 4. And finally, no, not quite finally, sorry, there's 2 more. So here's 1, that's a true node. And so I'm going to call that 5. And finally, this one here, which is another binary node, so call that 6. So altogether there are 6 nodes in this circuit. So that's including binary and true nodes. So just to recap there was two binary nodes, they were 6 and 2. All the rest are true nodes because 3 or more elements meet at each of the other nodes. Okay, that's question 1. So all you would do here is just type in the number 6 and we can move on to the next question. So question 2. In this question, you're asked specifically how many true nodes there are in the circuit. So here's our circuit again, and what I'm going to do is I'm going to colour in. This time I think I'll use red to indicate the true nodes, and I will use green to indicate the binary nodes. So I'll colour in the binary nodes first because those are pretty easy to spot. So we've got one binary node here. Why don't we call that B1? I've got another binary node up here. Call that B2. Got a binary node here. We'll call that B3. Binary node here. Call that B4. I think that might be it. There's one more up here. That's B5. So of course these are not the nodes you've been asked to count in this question. You've been asked to count the true nodes, but I'm just going to mark them off just so that you know that those ones, we don't get them mixed up when we're counting the true nodes. So now I'm going to mark off the true nodes. So I've got one up here, where I've got these three elements meeting. So let's call that T1, short for true node 1. Got one big one down here. So it spans all of this area here. So this whole corner of the circuit here, we'll call this one T2. And then finally we've got another true node here. So this, I'll call this T3. So the way you know if everything is all part of the same node is if you can get from one point in the circuit to another point without having to pass through an element. If there's a way to get there just by traveling along the lines without actually passing through an element, then you know that the start point and the end point where you started and finished have to be part of the same node. So therefore you can kind of fill up the whole area here with color here. That tells you how much is part of the node. The reason nodes are so important is that they the voltage will be the same at all points throughout this node here. So we talk about node voltages in the circuit. If we want to know the state of all the voltages in the circuit, it's sufficient for us to know the voltage at every node. So anyway, in this case, you have been asked how many true nodes are there in this circuit, and there are 3 true nodes. So all you need to do is type in 3. Now, of course, once you know what you're looking for here, you could probably answer that question in like about 5 seconds, but I just want to go through things carefully here to make sure it's clear why I'm putting in the number that I'm putting in. So, question 3. In this case, you are asked how many binary nodes are in the circuit. So, here's the circuit, and again, I'll use green to mark the binary nodes. So we've got one here, let's call that B1, got one here, call that B2, one here, we'll call that B3. Where else have we got them? Over here, call that B4, one here, B5, one here, which I'm going to call B6, and one here, which I'm going to call B7. Now, just to be sure here that we haven't missed anything, I'll just check that everything else is part of a true node, so any of the other lines in the circuit. When you've marked the binary and the true nodes, if you're colouring them in on a circuit diagram like this, there just shouldn't be any lines left that aren't coloured in either as a true node or a binary node. So there's one true node at the top there, and then there's another true node here. So yeah, that's everything coloured in there. So there's 2 true nodes only in this circuit. So how many binary nodes do we have? 1, 2, 3, 4, 5, 6, 7 binary nodes. And that's what you're asked for in this question. How many binary nodes are in the circuit? So let's type in 7. Now question 4. How many branches are in this circuit? So what we mean by branches, these are the paths through the circuit which connect any 2 true nodes. So the first thing I'm going to do here is I'm going to mark the true nodes. Now a branch can go straight through a binary node, so like a single branch can pass through one or more binary nodes. Like those binary nodes don't break a path up into more than one branch, but a branch can only begin or end at a true node. It can't go through a true node. So I'm going to mark the true nodes first. Got one here, call that T1. Where else have I got true nodes in the circuit? There's one down here, let's call that T2. One up here, call that T3, and one over here, which I'll call T4. Now I think I'm right in saying everything else here is a binary node. So I'm just going to double check that by colouring in all these. That's a binary node for sure. This one's a binary node. This one's a binary node. This one's a binary node. And this one's a binary node. The way you know if it's a binary node is if there's only two elements that meet at it, then it's a binary node. And finally this one here is a binary node. So we're not too interested in the binary nodes here. It's really the true nodes that are going to be important. So now what we're interested in identifying is what are the paths which begin and end at different true nodes without passing through any other true nodes. So I'm just going to count them up. Maybe I'll mark them off in a different colour here so that I can keep track of them. So we've got one branch here going from true node 3 to true node 2. So that's 1. I've got a path through OR2 which starts at T3 and ends at T1. So that's another branch. We've got a big long branch here going from T3 all the way down to T4. So that's my third branch. I think that's all of the branches now from T3. So there's basically a branch going in each direction from T3. So we've marked off all of them. So now I'm going to move to T1. Now we already have one of the branches leaving T1 because we already counted that when we started at T3. But there are two other branches here that I need to count. So there's a branch going down to T4. So that's going to be my fourth branch. And then there's a branch going from T1 to T2, which would be my fifth branch. Now we're almost done. There's just finally from T2 to T4, there's a branch through OR4. So that'll be the sixth branch. So how many branches did I have altogether? 6. So just to reiterate, each branch is a path beginning at one true node and ending at another true node, but passing through no true nodes on its way. So it has to begin and end at a true node, but not go through any true nodes along its path from the beginning to the end. You can go through as many binary nodes as you want, and therefore as many elements as you want. But as soon as you meet a true node, that's the end of your branch. So that's what we've done. Generally, the best way to kind of do this systematically is to mark off the true nodes and then look at them one at a time and, mark off the branches and actually write on the circuit diagram. At least that's the way that I find it easiest to do this. The reason branches are significant to us when we're analyzing circuits really is that the current through all of the elements in a branch at any point in time is the same. So in other words, the current through V2 or 5, V3 or 6, and I didn't actually mark a name of this, but this inductor here, at any point in time, the current through all of these elements is the exact same because they're all in one branch and they're all in series with each other. Okay, so that was question 4. How many branches? 6 branches.